Welcome to this lesson. This lesson I'm going to introduce classes to you. Introduction to classes. So basically, a class is the logical construct upon which the entire Java language is built, because it's defining the shape and the nature of an object. So classes form the basics of object-oriented programming in Java, and each concept that you as a programmer would want to implement in Java, that concept needs to be implemented, needs to be encapsulated rather around classes. It's very, very essential. It will needs to be encapsulated around classes. Now, what are the fundamentals of a class? A class actually defines a new data type that, once defined, the data type can be used to create objects of that type. In other words, when we create a class, we are defining a new data type, and we can use that data type to create objects of that particular type. It's also of essence to know that a class is a template for an object, and the object is the instance of that particular class. So to define a class, you need to declare the exact form and even nature of the class, and we normally do this by specifying the data that the class contains and also the code that is going to operate on that data. So the data that the class contains, we call them instance variables, and the code that the data is going to operate, the code is going to operate on the data, we call it methods. So to declare a class, therefore, we actually use the keyword. We use the keyword class. Okay, and classes, by the way, can get more complex, but let's just look at a very simple example of a class. So I want to create a class, a box class, a class that is box class. So we said we need the keyword. The keyword is class. So we begin with the keyword class, then followed by the class name. I want to create a class box, and followed by class name. I'm just showing you here, but we don't need to, we are not creating classes here, or rather, let me just put it where it's supposed to be. Now normally we create classes here. Yeah, you see below the package name here, that's where we are going to create the class. So let me just have the simple class. So class, the keyword class, followed by the class name, which is box, and then followed by parenthesis. So inside the we said the keyword class, then box is actually the class name. Now inside the parenthesis, we are going to declare our instance variables. So double, a box has length, so double length. A box has width, so double width. A box also has what? Height, so double height. So length, width, and height are, we call them the class instant variable. So the class that we have created right now is just a simple class. It does not have methods yet. We are going to add the methods later. Now, so we have defined a new data type, and this data type is called box, and we can use this data type to declare other objects of the type box. I want you to recall that I said a class creates a template of an object and not a real object. Thus, the code that I have written here doesn't bring into existence of any object of the type box. So for us to be able to create a box object, we need to use a statement like this. Let's come here. We have created the template. Now we want to create a box object. So we are going to create a box object and just call it my box. So to do that, you need to use the class name, so box, and remember we are doing that inside the main. Then we give our object a name, so it will be my box. My box is equal to, then we use the new keyword, new, then followed by the class. We are calling the class construct. We'll talk about that much later. Yeah, So this one creates a box object, and we have called the box object my box. This box object that is created here is created using this template here. It is created using that template above. So we are using the new keyword in that case. So the my box object contains its own copies of the instance variables of the class box. So it has its own copy of length, its own copy of width, its own copy of height. So if we want to access these variables, then we use what we call the dot operator to actually link the name of the object with the name of the instance variable. For example, we can come down here and say my box dot width to actually access that width. So we can store something in there. So my box dot width, let's store 10. Let's store my box dot length. My box dot length, let's give it 12 rather, and then my box dot height, my box dot height, we will give it let's say 15. It's height, not, yeah, it's height. My box dot height, so we give it 15. So for us to be able to actually access the variable of the class, we use the dot notation. We use the dot operator. So we take the object, then dot the object instance, the class instance variable. Okay, so although we commonly refer to this operator as a dot operator, the formal specification for Java actually categorizes the dot operator as a separator. We call it as a separator. Now, so we have actually created that. For example, let's declare another variable here. Let's say volume, double volume. Okay, let's declare that double volume to hold the volume of our box. So assuming that we want to get volume of our box, so we can now compute the volume here. So we say vol is actually equal to, then my box dot width, dot width. So we take my box dot width, we multiply it with my box dot length, we also multiply it with my box dot height. Yeah, so that you see now here we stored values in these variables. Now here we are using the values to actually calculate the volume. So we can print the volume. So system dot out dot print ln can print the volume, and just print vol, it shows us the volume. So if we run this code here, let's run our code and let's check the output. Okay, system.out.print vol, vol is equal to okay, so check here, the output is 1800, and if you take 10 multiplied by 12 you get 120, multiplied by 15 you get 1800. So we have created a class here, and we have used that class to create a new variable, a new object, and we called it my box. We have assigned my box some values, and we have calculated the volume of my box. Okay, now so we need to always what we actually need to know here is that since we have each object having its own copy of the instance variable, then it's essential to actually note that the changes that we actually make to the instance variable of one object will not actually affect the other instance variables. So we have a class here without methods. We have a class here, we have a class here that has instance variable and we have created an object. So while declaring an object, we do two things. The first one is we are declaring a variable of the class type that can actually refer to that object. Number two, we acquire an actual physical copy of the object and assign it to that variable, and we do that using the new. Now you see, this one is a declaration of an object. So if we break this one into two, it can be something like this. So box my box, then here we say my box is equal to new box. So this first line, box my box, is actually a declaration of the variable that is actually going to hold the object. So we call it my box. And then this one is allocation. This one allocates memory for the object actually. So when we use the new operator, it actually allocates memory dynamically at runtime for an object, and then it is going to return the reference to the reference of the particular memory to the object, which is actually more or less than an address in memory of the object allocated by new. Now then we store that reference in the variable. So when we just say box my box without this statement here, then we don't have memory allocated for this object. Now we can combine these two just the way I had combined them. Box my box is equal to new box. So I just splitted it so that you can get an understanding of what I am trying to say. So box my box declares the reference to the object, then my box is equal to new box actually allocates a box object. Okay, so after the first line executes here, the first line, this is box my box, after it executes, my box contains the value of null, indicating that it doesn't yet point to any actual object. So any attempt to actually use my box at this time will give a compile time error. So after this executes, let me just return it the way it was so that you understand what I am saying. So this is my box. So after this one executes, the values for my box actually are pointing to null. Okay, then my box is equal to new box. When this one executes, then what actually happens after the second line executes, now you are able to use my box like it were maybe a box object, because in reality my box simply is holding the memory addresses of the actual box object. Now we've talked about the new keyword. Let's look at the new keyword closely. Now we have box here. We have box here as a class variable. We have box here as the class type that we are creating. Then this one is the box variable. Okay. Then this is the name of the class from which or rather it is actually specifying the constructor for the particular class. This whole thing, if we take this whole thing here, is specifying the constructor. I'll talk about constructors later, but again here box is of course the class name. So a constructor basically defines what occurs when an object of a class is created. So most real world classes explicitly define their own constructors within their class definition. Java will actually automatically supply a default constructor in the event no constructor is specified. Right now we have not specified any constructor, so Java specifies a default constructor. So of essence, we need to understand that the new keyword allocates memory for an object during the runtime, thus giving the advantage of your program being able to create as many or even less objects as it needs. Now the essence of the new keyword is to enable us create many objects that we would need to create in our program, because the new allocates memory. Memory is finite, thus insufficient memory exists, meaning that we might not be able to really assign memory to some objects. Now this is going to cause some runtime exception, but I'll handle exception much later in the course. Now, how are actually objects assigning object reference variables? So object reference acts differently than our expectation. For example, let's look at this code. Let me put this code here. We have box 1. Let me just combine this statement, my box. Let me combine this into one. Yes. Now, if I come here and say box, something like box, and I say box with capital B, and I say box, then my box 2, my box, or my box 1, I say is equal to is equal to my box, is equal to my box. I want you to see something. I said box, my box 1 is equal to my box. So our expressions here could be that box 1, my box 1, or rather yeah, my box 1 is assigned a reference to a copy of the object that is being referred to by my box, meaning my box 1 and my box are referring to separate objects. So this is the expectation, but it is actually wrong. It is a wrong expectation, because both boxes here will all refer to the same object after the code is executed. So the assignment of actually the assignment of my box to my box 1 does not do any memory allocation or copy any part of the original object, but simply is actually making my box 1 refer to my box. Okay. Now, because of this, any changes that we are going to make to the object through my box 1 will affect the object to which my box is referring, since they are actually the same object. Okay, so it's important for us to understand. Now, despite my box and my box 1 referring to the same object, they are not actually linked in any way. They are not connected in any way. So we really need to get that understanding. I know right now things are a bit confusing, but we are going to understand better. We're going to understand better with time. I just wanted to show you that allocation. Now, so we have created a class that has no methods. So let me introduce you to methods.